everyone. We're gonna tackle the last section of radicals and complex numbers, and then we can quiz out of this section and we can start a whole chapter next week after spring break. So the last section, which is only a couple slides, is operations with complex numbers. Complex numbers are any number in the form a plus bi, where it involves an imaginary number. And the first thing we're going to have to be able to do is add or subtract them, which is very, very, very easy. All you have to do is treat I as if it was X, as if it was a variable. So right here, I'm going to take 3 plus 4I, and then I'm going to, in theory, distribute, but it's a positive. So it's plus -2 and minus 5I. Or you don't need the double sign, so you could just have minus 2I. So here, just pretend it's like a variable. If this was 4x and 5x, we would put them together to get negative 1I, and 3 minus 2 is 1 plus 1. So most times when you write, you would write it in the a plus or minus I bi form. So this is the form I'm talking about, a plus bi or a minus bi. That's the form complex numbers normally come in. So normally we put that first. Would I take this? Absolutely, I would take that. So the next one, the only thing we have to be careful about this next one is I'm going to get 3 plus 6i, but there's a minus here. And in theory, there's a -1 here. And so it has to be distributed. So it becomes minus 4 and plus 2i. Again, you treat it as if these are variables in a way. So I'm going to get 6 plus 2 is 8i, and 3 minus 4 is -1. And again, I'm going to put that I after. So what I would like you to do is try this one on your own. Okay, 7 minus 4i plus 5 plus 10i. So go ahead and take a second, try that one on your own. The next operation here. If you would you try this one on your own? The only thing you have to remember is when you have a squared, it does not mean to distribute. It means you need to write it twice. So we're going to write it twice. Go ahead and try that on your own, please, and let me know what you get. So if I multiply, I'm going to get 9. I'm going to get 12i. In here, I'm going to get 12i. And here, hopefully you realize, is 16i squared. That I squared is a much different answer than just I. So 9, I combine my i's because I have 12 of them and 12 of them, which makes 24i. And then now I want to change that I squared. So I squared becomes -1. And so that becomes -16. 9 minus 16 is 7, 9, 10, 11, 12, 13, 14, 15, 16. -7 plus 24i. So if you put it just simplify, get 5 over. Now, if you multiply that's k, you would then get 10i on top and 4i squared, which is -4. Not a bad answer, but 10 and 4 are both even numbers, so you would have to simplify to this. If you did that, it's absolutely fine. Not a big deal. Okay, we have one more thing to cover, and last thing we have to cover is when the denominator has I, but instead of being by itself like it is here, it's a group. And when I have a group, get rid of it. Just like when we did radicals, I had 6 over the square root of 2 plus 1, that was a group. And if you recall, in order to get rid of it, we used the conjugate, which was exactly the same thing, but a different sign. So now we're going to do exactly the same thing, except we're going to use the conjugate, which means the different sign. But what we have to remember is whatever I do there, I must do up top. So up top, simply going to be 10 minus 5i, not bad. The bottom, because it's a group and a group, it brings us up to the foiling that I have to do. When I FOIL, I get 4. When I FOIL here, I'm going to get minus 2i. Here, I'm going to get plus 2i. And then I'm going to get minus I squared. What you're going to want is the middles to cross out always. And so if they're not crossing out, you did something wrong. What we have to pay attention to is I squared is -1, but you have a minus in front of it. So it's really 4 minus -1, which becomes 4 plus 1, which is 5. So now my answer looks good. What you have to be careful about in this situation, though, if you're going to put these in the computer, here's what you have to be careful about. If all 3 numbers in the problem, 10, 5, and 5, can all be simplified, you need to. So this is going to be 2 minus 1i over 1, which is really just going to be 2 minus I. So for me, this is a great answer. For the computer, or if you were picking an answer on an SAT, it's going to be into this. All right, this is going to be a little tricky one, but go ahead, do your best, see what you can get, see if you pick the right answer. All right. Conjugate. Which is I squared. That I squared is going to become -1. My top's actually going to be 9 minus 20. Okay, so not bad, but all right. Bottom, 3 times 3 is 9. You're going to get your 12i. In here, you're going to get minus 12i. They better cancel. If they're not canceling, you're doing something wrong. And the last step, I hope you got right, should have been minus 16i squared. I squared's -1, making this 19 plus, I'm sorry, 9 plus 16. 10 plus 16 is 26. 1 away is 25. Okay, looks good for me, except the 15, the 20, and the 25 are all in the 5 family. So I can take out a 5 and get 3i minus 4 over 5. If you got here, great job. If you got, this is what you need if we're going to input the answers in Delta Math or an online assignment. All right. I hope you guys, that wasn't too bad. This is the last section that we need in order to get out of radicals and complex numbers, which will lead us to our next chapter, which is pretty exciting. All right, bye.